So we're now going to start Unit 5, which is about triangles. And this is the very first guided practice for Unit 5, Properties of Triangles, Day 1. The objective today is to find the measure of the angles of a triangle and apply the properties of midsegments. So you may have learned some of this before, and some of this vocabulary may be familiar to you, and then again, maybe some of it is new. But let's go ahead and let's review or learn some terms that we use when we talk about triangles. A scalene triangle. Okay, a scalene triangle is a triangle whose three sides are all of different length. Okay, so a scalene triangle is a triangle whose three sides are all of different length. Okay, now contrast that with an isosceles triangle, which is a triangle that has two equal sides. So an isosceles triangle is a triangle, that has two sides of equal length. Okay, so if all the sides are of different length, we call the triangle scalene. If the triangle has two sides of equal length, we call it isosceles. And an equilateral triangle, equa is in the word, is a triangle that has all three sides of equal length. Okay, a triangle where all three sides have equal length. So it's a triangle that has all three sides of equal length. And another property of an equilateral triangle is that it also has all three angles of equal measure. Okay? Also, all three angles have equal measure. And in fact, each angle is equal to 60 degrees. In an equilateral triangle, all three sides have equal length, all three angles have equal measure, and each angle is equal to 60 degrees. So what's the total number of degrees in an equilateral triangle? Well, all triangles have three angles, and if each angle is equal to 60 degrees, then you add 60 plus 60 plus 60, and that's 180 degrees. In fact, we're going to see quite soon that all triangles have their angles, all three of their angles add up to 180 degrees, not just equilateral triangles. And finally, we have another phrase that I would guess you haven't heard before, which is the midsegment of a triangle. We're going to talk a little bit about that today. A midsegment of a triangle is a line, segment, connecting the midpoint of two sides of a triangle, of two sides of a triangle. Barely fit that in there. Okay. So a midsegment is a line segment connecting the midpoints of two sides of a triangle. So the midpoint of one side is connected to the midpoint of the other side. So let's practice some of these definitions. Let's take a look at numbers 1 through 3. And here we need to classify each triangle according to its side measure first, and then find the midpoints of the non-horizontal sides and draw the midsegments. So let's first start by classifying each one of these triangles. And I'm going to use the little ruler that's built in to my protractor here. Let's look at this very first triangle. I'm going to measure the length of the side AB. Now in this case, let's see if inches would give us a better even amount. Let's see if we've got something here. Okay, this is just about 1.5 inches. Okay, so just a wee bit larger than 1.5 inches, the length of side AB. Let's look at the leftmost side of this triangle, and we see once again it's just a wee bit less than 1.5 inches. So these two sides are the same, and let's look at the third side of this triangle, and let's measure it as well. And you'll see it is exactly the same measure. It is also just a tad under 1.1 inches. So all three sides of this first triangle have equal measure, which means that all three sides are congruent. They all have equal length. Therefore, what kind of triangle is it? It is an equilateral triangle. Okay, let's look at the second triangle here. Maybe I'll zoom in on it a little bit, might make it a little bit easier to see the measures. Let's go ahead and measure side AB. We can do that in inches. Might help if I held this properly. Okay, let's see, we've got just about 2 inches. This side is about 2 inches long, the bottom side. Let's look at the left side. It's about 1.5 inches long. It's not the same size, right? The left side is 1.5 inches long. What about this slanted side near the right? That one is about, maybe 1 7/8, not quite, I'm sorry, 2 7/8, not quite 3. So they're all different sizes. So we've got to call this a scalene triangle, right? This is a scalene triangle because no two sides are equal. And let's classify this triangle finally, the one on the right. Well, you can probably guess it's supposed to be an isosceles triangle, right? Because that's the only type we haven't gotten to yet. But let's kind of confirm that. Let's measure AB. AB here is 4 inches, pretty much exactly. By the way, I'm supposed to have been writing down the length. I'll have to go back and do that for the other ones. But AB, the measure of AB is 4 inches. Let's look at the left side here. And that's 2.5 inches. And let's look at the right side over here. And that's also, we line it up exactly, it's 2.5 inches. Okay, so we've got two sides of the triangle of equal measure. The third side has a different measure. So this is an isosceles triangle. And let's just go back and make sure we fill in the measure of AB on all these triangles because we were sort of supposed to do that. So on this triangle here, we had 2 inches. And on this triangle, which was our equilateral triangle, we had 1.5 inches. Okay, good. Very good.